Welcome to the first video of our second unit on scientific notation. Please have your note packets out. Hopefully you have your name written already on it and your section color. So you will either be red, orange, or yellow. Today we're going to talk about just an introduction to scientific notation and what it is. We've seen a couple examples in class of scientific notation. And we use it when we have a number that's very, very large with many, many zeros in it, like the distance from here to the nearest planet, or a number that's extremely small, like the size of an atom. So it's an easier way to express very large or very small numbers. So scientific notation, it is a way of expressing very large or very small numbers that makes it easier to read, write, and calculate. Okay, so you can take a minute to write that down. So when we have very, very large numbers, it's inconvenient to be writing all those zeros, or if you have a very small number. So it's just easier to handle those large numbers. And the way we write a number in scientific notation is that there are two parts to the number. There's the first part called the coefficient that's in front of the multiplier of 10. So it's called a coefficient. And the coefficient that's out front needs to be greater than or equal to 1 and less than 10. And then it's multiplied by a power of 10. And then you have an exponent on the power of 10. And we've dealt with exponents before. So let's take a look at some examples so you can see what I'm referring to. So let's say that we have a very large number. So let's say that we're talking about a number like 300 million. So if we have a number 300 million, there are a lot of zeros to write down, and if we're multiplying with those zeros or rewriting them many times, it's inconvenient. So when the number is written like this is called standard form. Just like when we had exponents, when your number's written out the long way, it's called standard form. Well, we know from what we've done already that 3 million, this is 3 times 1 million. Okay? And we see the number 1 million has 1, 2, 3, 4, 5, 6, 7, 8 zeros in it. So we can rewrite this number as 3 times 10 to the 8th. And this number is called scientific notation. This is scientific notation. It's still equal to 3 million. It needs to be equal to 3 million, but it's written out in a form where 3 is called the coefficient. So this is the number we were just talking about. 3 is called the coefficient. It's the number multiplied out front. And the coefficient always needs to be between greater than or equal to 1 and less than 10. And then it's multiplied by a power of 10. So when I see 3 times 10 to the 8th power, I know that this means 3 million because I'm multiplying 3 times 1 million. Okay? Okay, now let's try rewriting a very, very small number in scientific notation to see what that would look like. Okay, so here we've written the number 0.00000458. So if we look at this first zero after the decimal is the tenths place, and then it's the hundredths, the thousandths, the 10,000ths, 100 thousandths. The 4 is in the millionths place. The 5 is in the 10 millionths place, and the 8 is in the 100 millionths place. So this is 458 100 millionth. In order to rewrite this, I'm going to focus on the non-zero digits, and I'm going to write 4.58. Now I can't just change the number to 4.58. So what I'm going to do is I'm going to multiply it by a factor of 10 that would make it back to the same number it was before. And we just said that the 4 was in the millionths place. So this is times 1 millionth. 3, 4, 5, 6 zeros. Now, we learned in our exponent unit that we can rewrite this as 4.58 times 1 over 10 to the 6th, because it's got 6 zeros, so that's 10 to the 6th. And if we have 1 over 10 to the 6th, that's equal to 4.58 times 10 to the negative 6 power. So if we have a very, very, very small number, it's going to be multiplied by a power of 10 that's negative. The negative power of 10, again, doesn't mean that it's a negative number. It means that it's a very, very small number, less than 1. So that's how we write very small numbers in scientific notation. The decimal always has to go after the first non-zero digit, so that this number in the front, so that the coefficient right here is greater than or equal to 1 less than 10 times 10 to some power. Now let's take a look at the next questions. It says tell whether each number is written correctly in scientific notation. If it is incorrectly written, state the reason. Okay, so number 1, a horse chestnut has a diameter of 2 times 10 to the 0 power. Well, first I look at the 2, the coefficient, and I think, is that between 1 and 10? It is, so it looks fine. And it's times 10 to some power. It's unusual to have a 0 power, but it's totally fine. So yes, this is written correctly. There's no problem with that one. Number 2, Neptune is about 4.488 times 10 to the 9th kilometers from the sun. Well, again, first I look at the coefficient, and I think, okay, is this number greater than or equal to 1? Yes. Is it less than 10? Yes. So it's between 1 and 10, that's okay. Times 10 to some power. Good. So this is also in scientific notation, so this is fine. Number 3, the approximate wavelength of infrared light is 0.01 times 10 to the negative 5 meter. Well, this is a very, very small number because the exponent is negative. But I'm looking at this number here, the coefficient, and I see the coefficient 0.01 is less than 1. So no, this is not correct. And the reason it's not correct is because the coefficient is less than 1. So because the coefficient, which in this case is 0.01, is less than 1. Is less than 1. So that means it's not in scientific notation. Okay, and then let's take a look at the next one. It says number 4, a football field, excluding the zones, is 10 times 10 to the first yards long. Well, again, let's look at the coefficient. Is the coefficient bigger than 1? Yes. Is it less than 10? No, it's not less than 10. So here, again, the coefficient is the problem. So no, this is not in scientific notation, and the reason is that the coefficient is too big. So the coefficient is too big. Now let's turn to page 2, and let's practice writing these numbers in scientific notation. I'll do number 5 and 6 with you. So in number 5, I have 427.7. Now, when I rewrite a number in scientific notation, the decimal has to come right after the first digit, the first non-zero digit. So I'm going to put the decimal right after the 4. So this is 4.277. Okay. Now I've changed the number. I don't want to change the value of the number, so I'm going to multiply it by a power of 10. Now, since this number is a big number, much greater than 1, I see that I moved the decimal places 2 places. So it's a power of 2. It's 10 to the second power, because if I multiply it by 100, it goes back to that place value. So this is going to be 4.277 times 10 to the second power. And again, 10 to the second power is 100, because if I multiply 4.277 by 100, I get back 427. I don't want to change my number. I'm just rewriting it in a different way in scientific notation. In number 6, this is a very small number, less than 1. In the thousandths, this is 7 thousandths. So again, I'm going to rewrite it by putting the decimal right after the first digit. So it's 7, or 7.0, times 10. Now, when I did that, I had to move the decimal 1, 2, 3 places. So when I'd have to put it back, it'd have to go back 3 place values. So this is going to be times 10 to the negative 3, because this is a very, very small number. When I put the decimal back, this becomes 7 thousandths. So when you're dealing with a very small number, less than 1, it's going to be a negative exponent. So pause it now and try doing the same for 7 and 8. Okay, so take a moment to check your answers. In number 7, the decimal should go right after the 8, and it's going to be times 10 to the third, because the place value had to move 3 decimal places, 3 place values. In number 8, the exponent on the 10 is going to be negative, because this is a very small number, less than 1. And we had to move the decimal place 2 places. So this is 6 times 10 to the negative 2. Okay, so now in the next set of exercises, we're going to try putting the number back in standard form. It's already in scientific notation. We're going to put the number back in standard form. So the way I do that is I'm going to write the number 7 in the digits 7 and 1. Now the decimal place currently is after the 7, but I see that it's times 10 to the third. So I know I'm going to move the decimal place 1, 2, 3 place values, because 10 to the third is like multiplying by 1,000. So I'm going to move the decimal 3 place values. So when I do that, I get the number 7,100. Okay? Now please press pause and try 10, 11, and 12. Okay, so now please check your answers. For number 10, it should be 90,000. In number 11, the decimal has to move 3 place values. So it's after the 8 moves 1, 2, 3, so it's 0.00812. In number 12, it had to move 2 place values to the left. So it starts after the 2, it goes 1, 2, so it's 0.025. Okay? So now the next exercises have to do with comparing 2 numbers to see which one is bigger. So the first says, identify the greater number in each pair, justify your reasoning. So here we have 5.6 times 10 to the second and 2.1 times 10 to the third. So take a moment to think about which one would be bigger. Okay, so hopefully you've had a chance to think, and I see that this one has 5.6 times 10 to the second, whereas the next one has 2.1 times 10 to the third. So even though this coefficient is smaller, the power of 10 is much bigger. This is in the thousands, whereas that's only in the hundreds place. So this second number, 2.1 times 10 to the third, is bigger because it has a much bigger exponent, has a bigger power of 10. Okay, so for number 14, I have 3.4 times 10 to the negative 1 and 1.1 times 10 to the negative 1. So this time, they both have the same power of 10. So that's the first thing I want to compare is the power of 10. Since the powers of 10 are the same, then I have to look at the coefficients. So since this first one, 3.4, has the bigger coefficient, this is going to be the bigger number because they have the same power of 10. And if we want to take a look at it, we can see 3.4, I'm going to move it just one place to the left because the exponent is negative 1. That's going to be 3.4, or 0.34. And then you have 1.1. Again, I'm going to move this one place value to the left to put it back in standard notation. So I see that the 0.34 is bigger. Okay, so now what I'd like you to do is read through questions 15, 16, and 17, and give those a try on your own. And we will discuss the answers in class. And as always, make a note of any questions you might have, and we'll go over them then. Thanks very much.